Actually, it's a dramatized version of the history of web development, but it will still be brief. So back in the day, when we wanted to create like a Hello World application, all we had was basically C. This is the amount of C code that you needed to make a CGI bin application to display Hello World in the web browser. And in case you're wondering, this is the zoomed out version of the main function, and everything else is just boilerplate. So it wasn't a very pleasant experience. So then this guy came along. Who knows who this is? This is the inventor of the Perl programming language and goes by the name of Larry Wall. So with Perl, we were able to express our CGI Hello World program a little bit shorter. It looks like a scripting language, which it is, and it's a little bit more concise and a bit more handy. So, but it's still kind of not optimized for the web. So, and then this guy came along. Who knows who that is? This is the inventor of PHP. Goes by the name of Rasmus Leerdorf. So with PHP, we arguably had the first programming language that was particularly designed for web development. So you had like already functions like HTML special characters embedded into the core of the language, and you could also embed like your programming code within an entire HTML document. So, but this is not a talk about programming languages. The reason I mentioned PHP is a program that looked like this back in the day. And this is actually a FTP program. And the way it worked is you took one file, your index.php, you put it to an FTP server using that ancient program, and then, poof, you got a website. Welcome. So this actually gave birth to the internet giants such as WordPress, Wikipedia, or the Facebook, two of which to this day still run on PHP. So at that time, people start to realize, well, there might be something about that whole internet thing. And software developers started thinking about software in the context of the web. So what they wanted to do is actually using the languages of their choice, such as Java, or Microsoft.NET, or Ruby, or Python, or Groovy, Haskell, Elixir, or Clojure. So this was actually the time when the first framework wave started. So actually at that time, a lot of web frameworks, as we call them back then, today you would call them server-side generated full-stack frameworks, were like invented, such as Spring, ASP.NET, Rails, Grails, Django, Phoenix, and not to forget, DOS on Dope. So there was only one problem. Our beloved FTP program wouldn't work for deployments. So now what? So things started becoming a bit confusing. But at the end of the day, we ended up with something called Docker. So this way we could use the programming language of our choice, bundle it together with the most crucial parts of the operating system to end up in something that we called a container. And that container we could run basically everywhere. There was again a problem. Those containers were like isolated environments, but you needed to orchestrate them. So you needed to tell them in detail what to actually do. Like, do we have replicas? Do we have, I don't know, scaling groups and something like that? So that eventually led to the invention of Kubernetes. So in Kubernetes is actually like, it can easily become like a behemoth of complexity. So that made developers a little sad. So they started thinking, what if we could just go to the good old days of having those single file deployments? So luckily, AWS came up with a solution for that, which they called AWS Lambda. And the promise was, give me your code. Instead of an FTP program, have a little deployment script, and boof, here's your website. So what's the problem with that? The problem is this is good for like talks like this, for quick start, because it just looks good. But real applications need a bit more context. They need databases, files, persistency, authentication, and whatnot. So luckily, AWS wouldn't be AWS if they didn't come up with a solution for that as well. And they named it CDK, Cloud Development Kit. So this actually is what infrastructure as code is. So you had a code file defining all of these services in the programming language of your choice, hit one button, and you have all of your infrastructure deployed to AWS. So we had, for example, IAM roles, Lambda functions, and Lambda function URLs. So what CDK did, or still does, is it mimics the cloud primitives that AWS provides you. And now a question, how many services are there in AWS right now? Yeah, a lot? Any guesses? It's about 250 or something. So it's easy to lose track about them. So, and it does not very well integrate with your application code. So we see what that means in a second. So this talk is only 25 minutes, and we already had the history lesson. So it's time to hurry up to build an Instagram clone. So let us first define how it should look like. So we have a website where you could add a message and upload a picture. You have another website where you could look at those uploaded images. And the moment I can put some message and upload an image here, the moment I hit save, this should get me a success message. And at the same time on the view function, it should like in real time update the posted images. This is kind of the architecture diagram, how we would use that, how we would build that on AWS serverless. So basically what it does is the user goes to an endpoint, which is a CloudFront distribution, which then has access to an S3 bucket to host the static website, which is the React app that you just saw. And from there, you use an API. This API goes to DynamoDB, stores the messages, goes to another S3 bucket, stores the images. DynamoDB itself has a functionality called streams, so it itself can call back a Lambda to update all those WebSockets. It's a bit complicated, admittedly, but all of these connections that you see here between these services is actually something that those frameworks that I talked about in the beginning did for you. So you lose all of that opinions about how you would stitch together your software. So let's see how that works in action. Let's see if the Wi-Fi works. So I have a code space. See if that works. Works like a charm so far. So there it is. So is the font size large enough for you in the background? Okay, so this is basically what we do now with SST. So we start with like a regular project folder where we have one file for each Lambda function, but we also have like an entire project folder, which somehow isn't loading right now. There it is, which contains an entire Vite project that renders our React app that I just showed you. So this has its own Vite config, and to bring that all together in the root level of the project, we have something like an sst.config.ts. And there, in a similar way as we would do in CDK, we can define the resources that we need. One thing that I want to show you is the static site. Let's see where that is. Like instead of, as you would do with CDK, instead of defining an S3 bucket, then defining the CloudFront distribution, then defining the IAM role between the two, and doing all of that, you could just use SST's built-in static website, point it to a directory, to that directory where we store our project, and it will do all those things for you. And same goes for like the Lambda functions. Our submit function that we use to post those images is just a pointer to a function stored in a file. In this file, the submit handler file, which is the submit TS over here. So then there is another file, sst-env.d.ts, and it says, okay, this file is auto-generated, please do not touch it. But as you can see here, this file is quite empty. We will see what happens when we run our deployment. So I just go and say boonix sst deploy stage dev. See what happens. At least it says deploying. Should do it. Let's give it a few seconds. Okay, while it's doing it, any questions so far? Okay, very good question. So it's does support. So it usually so the up until the second version, I guess, of SST, it was supporting only AWS because it was built upon CloudFormation. Now with version 3, it is built upon Pulumi. So technically, it supports every provider that either has a Pulumi provider or like a Terraform provider, because Pulumi supports Terraform providers. In practice, it's still very much centered around AWS because it carries all those opinions about it. But you could also, for example, use it very well with Cloudflare Workers. Most of them, because in fact, like this is a feature that I don't show because of the time constraint here, but I have a slide on that I don't show it. But what SST does is it can provide the entire infrastructure in AWS. And if you have, for example, a Lambda function, it tunnels back the entire traffic to your local machine so that you can run your code on your local machine, but still use it in the browser as if you were on the AWS infrastructure. So, and that works for even the static website. If we look, for example, at, they have a dev command built in, which does exactly that. Like in the background, it runs the dev server of Wheat, and it can tunnel back all that stuff to you. So is this different compared to Terraform? Or is yeah, well, again, like technically, SST is a layer on top of Pulumi. Pulumi is kind of a layer on top of Terraform, if you will. What it does, it adds some, so like AWS in and of itself, like has very small building blocks. So they are aiming for 99% of use cases. But there are only so many ways of how you can combine those primitives to make, let's say, a REST API running, right? So what SST does is they're aiming for 80% of the use cases and bring you those opinionated stack that's just easier to reason about. But internally, they're just boiling it down to the smaller components. With the static website construct there, you can access like deeper methods like the ACL, bucket policy, or like customer managed keys with S3 buckets that are part of that. Yeah, it will do everything for you. It will do exactly that. It will set up the S3 buckets, the IAM policies, the CloudFront distribution, and whatnot. Yeah. Yeah. So basically, you can if there is a setting in the underlying Pulumi provider, you can override all those settings. Yeah, well, okay. That is actually the thing I'm waiting for, because like, okay, let's pretend it had deployed. What we would see is that this sstenv.d.ts file would get updated. So, and then inside, for example, your Lambda function, you see this Lambda function needs to connect to my DynamoDB table. And the magic source that SST adds here is I can get rid of process.env. Because I can just say import. So now it's done, by the way. Let's see if it works. So, yeah, basically I have a website here. I can, let me open the view tab side by side. And it works. Okay, cool. So what happened behind the scenes? This sstenv got updated. So, and then inside my Lambda function, I can get rid of process.env by saying import resources from SST. And then say, instead of process.env, I can say resource.messages table. So, and this is basically what sets it apart. It integrates into your application code while being deployed. So, and behind, really behind the scenes, they also have a console. And you remember that infrastructure diagram that I just showed you that had like 10, 15 services? In reality, it put out like 70 building blocks to make that all work. So, okay, obviously the Wi-Fi did work, so we don't need the video. So the two takeaways here. Like the first thing is that you just mentioned, the import resource from SST, that is a deep integration into the application code itself. And the other thing is opinions, lots of them. So basically we've seen all of these things being deployed without us interfering with them. We could override it, yes, but we don't need to. So, and not shown is the local development stuff. Like you are able to run the Lambda inside AWS, but tunnel back the traffic to your local machine. That's also very cool if you want to run a local debugger. But the one thing that we haven't talked about is scalability. So there's horizontal scaling for sudden traffic spikes, auto scaling or replicas and stuff like that. And on the other hand, I would have vertical scaling, which would roughly be that picture. Just buy a bigger server. Well, because 80% of companies don't run TV ads. And 80% of companies don't have like a real global audience. What about latency to the edge, latency to the customer? So this is basically a matrix of the interconnection latencies between AWS regions. So, and if you go that way or that way, you see that if you put everything in US East 1, you would be able to serve North America, most of Latin America, and most of Europe within less than 100 milliseconds. So it's really a question if, do you need to get better, really, for the sake of building a distributed system? So, because like when you talk about scalability, this is what people think it is. It's about network and connectivity and distributed system. But in 80% of the use cases, it's not. It's about this. It's about how people collaborate on the software project. So you scale more in people than you have the need to scale technically or for traffic. So I'm not here to tell you that all of this is useless. In fact, there are use cases for microservices or serverless. Here, telltale signs that you might need it. So you have frequent merge commits to your monolith. might be a good time to split it up to microservices to have teams working on individual components. If you need to scale from tens of people to hundreds of people, or even higher in a short amount of time, or if you really, really have that global user base in, I don't know, Middle East, Asia Pacific, or what else, or if you just want to ride the latest trend, well, that actually is a red flag. Don't do it for the sake of doing it. Please do not. So there are still open questions that we can't cover in the last 3 minutes. So one of which is, how will the boundaries between developers and operators like merge or will blur over time? Because that's what DevOps originally promised. I had a conversation with Doug Rad, who's actually one of the co-founders of SST on my podcast. So if that's a conversation that you might want to jump into if you want to learn more about that. Sorry. And the other question is, how can we migrate from, like, let's say, a monolith to a microservices architecture? I had a great conversation with some guy from AWS by the name of Luca Mezzalira, like just the other week. So where we go deep into that. You will find those episodes on my podcast at bas.fm. So now we have time for a little commercial break. Is anyone using Python? Oh, very cool. So Stelvio is an open source project that I'm working on together with another guy. It's basically what SST does for JavaScript, but it does it for Python. Check it out if you are using Python, if you want to do something with it. It's a very early stage, where we got a couple of things running, including AWS DynamoDB and stuff like that. So I think 2 weeks ago, we released also like a static website component. So it's stelvio.dev. So, and if you take home only 2 things out of that talk, that would be, in 80% of the use cases, you scale more in people than you have a need to scale in traffic. And the other thing is, in 80% of the time, it is better to have a framework that has opinions that you can use than to build upon those cloud primitives for yourselves. Any questions? Sorry, I didn't get that.
With SST, can you use that as your infrastructure as code, and then for the handlers on those individual lambdas, point that out to Python handlers?
Well, actually, it might be technically possible, but I never tried it. And it's just not designed for that, because it's designed for like TypeScript/JavaScript.
I just wanted to add about the scaling for traffic. I think EC2 now gives you a machine with terabytes of RAM.
Yeah, that's a lot of RAM. That's a lot of RAM. So then the machine is going to ask you a question. No, just kidding. But seriously, we are at a conference with a $49 ticket, so go buy some merch, because all of that's going to charity as well. Visit the sponsor booth, and please leave a feedback like on the conference overall and on that talk. Thank you. Well, 3 seconds left.